Welcome to this explainer. Today, we're demystifying the alphabet soup of modern electric vehicles. If you've been tracking the EV space even a little bit, you already know the acronyms: BEV, HEV, PHEV, FCEV. But using the official breakdown provided by Niti Aayog, which is the government of India's premier policy think tank, we're actually going to look under the hood. We're going to decode exactly how energy flows in these different vehicles and figure out what it all means for the future of driving.
Okay, let's look at our roadmap. We'll start with the EV alphabet soup, then dive straight into the four distinct architectures: BEVs, HEVs, PHEVs, and FCEVs. Finally, we'll wrap up by asking, which drives your future? Section 1. The EV alphabet soup, demystifying the acronyms. To really get these vehicles, we need to look past the jargon. Instead of just seeing a bunch of letters, think of them as highly engineered, unique solutions for reducing emissions and maximizing efficiency.
Section 2. BEVs, all-electric power, the grid-to-motor journey. So, let's start with the battery electric vehicle, or BEV. This relies completely on the electricity grid. Zero fossil fuels, absolutely zero tailpipe emissions. You essentially plug it in like a giant smartphone to fill up a high-capacity, floor-mounted battery. And because there's no heavy combustion engine weighing it down, it's incredibly efficient. Pop the hood, and it's actually a beautifully simple mechanical puzzle. Without an internal combustion engine, thousands of moving parts are just gone. You're left with the electric motor, the inverter, the main battery, a control module, and the drivetrain. That's literally it. Fewer parts mean significantly less mechanical wear and tear, which is obviously a massive shift from the cars we all grew up with. Let's trace that energy flow, right? Direct current, or DC power, sits in the battery, but the motor needs alternating current, or AC, so the inverter converts that power. When you press the accelerator, a signal shoots over to the controller, which adjusts the AC frequency to tell the motor how fast to spin. And here's the coolest part. When you hit the brakes, the whole system basically works in reverse. The motor becomes an alternator, creating drag to slow you down, and it actually captures that kinetic energy and sends it right back into the battery. It's called regenerative braking, and it is an absolute game changer for extending your range.
You've definitely seen some of these famous faces out in the wild. Manufacturers globally are bringing this all-electric architecture to the masses. Cars like the Tata Nexon, the Hyundai Kona, the MG ZS, these are pure BEVs. When one of these silently glides past you, you now know exactly what's happening underneath. Pure, grid-charged electrical power.
Section 3. HEVs, the classic hybrid, the gas-electric tag team.
Now, a hybrid electric vehicle, or HEV, is probably what pops into your head when you hear the word hybrid. Unlike the BEV, the HEV absolutely cannot be plugged in. It has a battery and an electric motor, sure, but it relies primarily on a standard fuel tank. The petrol engine pulls double duty here. It drives the wheels, and it acts as a built-in generator to recharge the battery when it runs low. Because we're essentially mashing two distinct worlds together, the architecture gets a bit more crowded. We have a traditional combustion engine and an electric motor working together. We have the battery pack, controller, and inverter just like the BEV, but we also squeeze in a fuel tank. It's a tighter fit, but the tech lets these parts communicate and share the workload flawlessly.
The energy flow here is fascinating because it's a dual-path system. The fuel tank feeds the engine, the battery feeds the motor. But here is the magic trick. Both of them can turn the transmission at the exact same time. The car's computer makes split-second decisions about whether to use gas, electricity, or a mix of both, maximizing your fuel economy without you ever having to hunt down a charging station.
Section 4. PHEVs, plug-in hybrid power, the best of both worlds. Okay, so a plug-in hybrid electric vehicle, or PHEV, neatly bridges the gap between our first two vehicles. This tech lets you pull electricity straight from the grid, just like a fully electric BEV, but it keeps the safety net of a traditional fuel engine, just like an HEV. You get a significantly larger battery than a standard hybrid, and crucially, you get a plug. Let's clear up a common point of confusion right now. Think of an HEV as a closed loop, where the engine charges the battery, but a PHEV plugs into a wall. This gives it a massive superpower. It can drive in pure, all-electric mode, entirely bypassing the gas tank, before it seamlessly drops back into being a standard hybrid.
Because it spans both of these worlds, the PHEV has the longest component list. It has everything the HEV has: the engine, motor, fuel tank, and that larger battery. But it also adds a crucial battery charger mechanism so it can actually accept power from the grid. It is literally the Swiss Army knife of electric vehicles.
The working principle is basically a relay race. Say you leave home with a full charge. The battery runs the first leg of your trip with 0 emissions. For a lot of commuters, that covers the whole day. But once that battery runs dry, there is 0 range anxiety. The combustion engine takes the baton, and you're driving a standard hybrid until you pull into your driveway and plug it back in.
Manufacturers are leveraging this tech across the board, from everyday drivers like the Chevy Volt all the way up to luxury powerhouses like the Porsche Cayenne SE Hybrid or the BMW i8. Sometimes they use PHEV tech to maximize commuter efficiency, and sometimes they use it to deliver an absolute jolt of high-end performance by firing the electric motor and the gas engine at the exact same time.
Section 5. FCEVs Fuel Cell Tech, the chemical powerhouse.
Now, unlike everything we've talked about so far, an FCEV is a true zero-emission vehicle that you don't plug into the grid at all, period. Instead of storing outside electricity in a giant battery, an FCEV is basically a miniature onboard power plant. It generates its own electricity on the fly through a chemical reaction, usually using hydrogen.
Under the hood, things look wildly different. That heavy floor-mounted battery pack from the BEV, gone. Replaced by a high-pressure hydrogen storage tank and a highly specialized fuel cell stack. You still have an electric motor turning the wheels, but the source of your electrons is entirely chemical.
The magic of the FCEV is literally just chemistry. You pump hydrogen gas into the tank, it enters the fuel cell stack, and mixes with outside oxygen. That reaction creates electricity that shoots directly to the motor. The only byproduct coming out of the tailpipe? Pure water vapor. It's an unbelievable piece of science happening right there inside the car.
Now, these are definitely rarer than battery electric vehicles, mainly because we're still building out the hydrogen fueling infrastructure. But these vehicles are very real. The Toyota Mirai and the Hyundai Nexo prove this zero-emission chemical tech is successfully functioning on roads right now. Plus, refilling a hydrogen tank takes just minutes compared to plugging into the grid.
Section 6. Which drives your future? The path to zero emissions.
Well, we've decoded the alphabet soup. You now know the simple mechanics behind BEVs, the tag team effort of HEVs, the relay race versatility of PHEVs, and the chemical brilliance of FCEVs. The big takeaway here is that electrification isn't a one-size-fits-all thing. It's a whole menu of incredible, innovative solutions. So knowing how energy actually flows through each of these architectures, which technology do you think is going to replace the gas pump for good in your own life? Will you plug into the grid or fuel up with hydrogen? Think about that the next time you see one of these vehicles silently gliding past you. Thanks for joining me on this deep dive, and keep your curiosity fueled.